point. So now, student, I'm going to discuss 24th January second shift paper, right? So my dear, so now, student, I'll discuss question paper one by one, right? So, student, this is the first question, right, my dear? A uniform rope is supported by two, maybe in the question visible for you, everyone. Okay, fine, my dear. I hope, yes, it's fine. A uniform rope is supported by two level pin support as shown in the figure. Mass of the rope is M. Okay, student, what's the mass of the rope? This is what M. Find the tension at the midpoint. Okay, fine. So we have to find tension over here. Very nice. It's not, it's a class question. It's not tough. It's literally very easy questions. Literally, it's been very easy questions. So student, have a look on the package solution part of the question. Don't worry, I'll go slowly. I'll go slow to discuss the question so that you can understand easily. Student, what you can say for this entire things. This is beta. I think that this is connected from here. So the because the string in the string tension always acting along the string. What might be tension always acting along the string. This is the I can say hinge point beta. Due to this, what you can say one tension force acting in this direction. So student, I'll make a BT of this point. Right, my dear. So you can say for this point, which is this is basically beta. You can say tension acting in this direction. Strategy for balancing, you can say one tension acting in these directions. Let us suppose I'm calling this is T. We wish to find beta. What is it? I can see. Let us suppose I'm calling this tension is what T dash or T prime. Student mention the questions. That is beta. Hinge point angle from here. That is what my dear. This is a 30 degree. So you can tell student this is what remains my dear 30 degree, right? So, entire mass is what? You can say, what, my dear? That is what? Basically, capital M means M. So, student, here I'm considering in vertical directions. Mass is what? Acting student. I hope you can easily understand. Because the class at physics one, literally you can understand because I'm always explaining. I always explain the questions like literally you can understand easily. Beta. So, this is mc by 2. Now, beta, I can take tension, tension component beta, right? So what tension belongs to quantity vector data. So I can take this component of tension. What my dear? This is you can write beta t cos 30. What a student you can write this is t cos 30 degree. One more student you can write this is t sine 30 degree. Student, now simply just equate the forces. Vertical forces, this is the vertical forces is equals to mg by 2. This is the horizontal forces is equals to t dash. That's all, my dear. So here, students, you can equate, I can say, equate force, student, equate force in horizontal direction, my dear. Right. So we can say, beta, this is t cos 30 is equals to t prime, beta. This is because these two are what? Horizontal forces. You can write, my dear, t cos 30 degree is equals to beta t prime. Say equation number one, my dear. Then a student, you can say this is the vertical forces. So now I'll equate forces in vertical direction. So what a students? T sine 30 degree is equals to what, my dear? mg by 2. Say equation number one. Sorry, equation number one. Now beta, just equate, just divide beta g. Divide beta, I can see equations second by first. Now beta, So what you will get, you can say just dividing this way. T cancel bacha. You can say this is tan 30 degree is equals to what beta? Is equals to what, my dear? Mg by 2 and t prime. Tan 31 by root 3 beta g. So you can do beta further, my dear. 1 by root 3 is equals to mg by 2 t prime. Finally, student is supposed to write answer of this question. What, my dear? Root 3 mg by 2. So, student, this is the answer for this question. Then which option is correct, my dear? Any option is there? Yes, 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 yes. Option Bombay is correct answer. Yes, student, please take what you wanted to say. Uh, student, I didn't get. Can you repeat again, please? Sir, take the TGN. Beta, can you write what's the meaning of PTN, my dear? Definitely, I'll respond, student. But I didn't see your chat. Now, beta, now have a look next question. What question says, find force on charge Q, 1 microcoulomb, due to uniformly charged rod as shown in the figure. Okay, no, it's a class question. Literally, and it's a class question. I mean to say it's a standard questions. Each and every teachers must done in the classroom, must have done in the classroom. So, beta, just have a look at of these questions. No, what is standard of this question, beta? I'll go slowly, bacha. That's also that's a night because there is no any such disturbance during live, right? So, beta, what is the things here, students? Beta, if your variation of force or anything in a linear directions, beta, what is the way to do these questions? Students, you have to just recall center of mass, rotation, or gravitation as well. Students, what is the way to do these questions? Student, length is everything mentioned. I'll take data in last. Let us suppose initially I'm considering as a what? I can say normal questions. You can see beta. This is what I'm considering lambda over here, beta. Right. So now students, just you can move x. Student, it's a variation in a linear way. If your variation in linear direction, then student, what you can take, you have to move x. You have to move x, student, and take element dx. Beta, always be remember it's a very, very important step to do this question. If anywhere variation is linear, then you have to move x and take element dx. Student, you have to move x and take element dx, right? Okay, now beta, I can say for this question, you need because now you have to move x and take element. How much beta z? This is element is dx. So you need to write what is the elemental charge. What there? What is the elemental charge? So you can say this is dq. You can write beta z. dq is nothing but it's lambda into x. dq is what? Nothing but it's lambda into x. They wish to find what is the force on 1 coulomb charge due to rod. So student, you need to write what is the force expression. Student, here I'm going to use formula due to point charge according to Coulomb's law. K Q1 Q2 by R square beta. So this is you can say K. This is Q remains fixed. This is what, my dear? You can say dq. What's the charge separation? X. So you can write x square. Now beta g, just integrate both sides. In last, I'll fit entire values beta. So what we will get, this is f is equals to beta, and also you can apply the limit. So no, everywhere I'm considering it's a normal questions, right? So I'm considering as a class question. This is A, and this is what beta is LR. So what is initial point of student? This is A, and finally beta what I can say, this is A plus L. So beta I can write KQ. I hope all of you remember it's a very common integration. Dx is upon x square. What, my dear? Minus 1 by x. What, my dear? Minus 1 by x. So this is beta kq. You can write this is, and dq is what beta? dq you can replace first here. Then you can apply integration. I'll write one more step. So this is student. You can see df kq lambda beta. This is dx upon x square. This is what, my dear? Dx upon x square. Now, beta, again, you can, now apply limit, beta. Limit remains same. This is a, and this is a plus l. This is a, and this is what, my dear? A plus l, right? Then, bacha, you can say this already I said, beta. What is the integration? So, force beta, you will get k q lambda minus 1 by x limit a to a plus n. Student, just I'm considering as a normal question. In last, I'll replace all data according to questions given. Then beta f is equals to k q lambda beta. Apply the limit here. So what you can say 1 upon a minus 1 upon a plus l. Now beta party just will go through according data here. So this is a beta k 9 into student. I'm feeding the value 10 to the power 9 and q which are 1 coulomb here. So students, here I'll write, student, here I'll write, my dear, 1 into 10 to the power minus 6. As I said, in last, I'll take all data. This is lambda beta. Lambda you can find what's here. Lambda is what, my dear? This is, you can say, charge per unit length. So beta, what is charge, my dear? This is for rod, rod lambda only for rod beta. So this is what? 2 microcoulomb. So 2 into 10 to the power minus 6. And what's the length beta z? 10 centimeter. So you can see this is 1 in, sorry, 10 into beta, 10 into 10 to the power minus 2 beta. You can say 1 by 5. So 1 by 5, beta will goes up here. This is 10 to the power minus 4 beta. 1 by 5, 0.2 you can say. So lambda beta I can say this is 0.2 into 10 to the power minus 4. Just beta, just multiply, divide 1 here. Then you can say lambda you can write 2 into 10 to the power minus 5 coulomb per meter. Now bacha, here I'll put this lambda value 2 into 10 to the power minus 5. Beta, this thing just we can solve further, student. This is 1 upon a. So 1 upon a beta what? This is 2 centimeter. So we can say 1 upon 2 into 10 to the power beta minus 2. Minus here, 1 upon beta. This is what? 12 centimeter. So we can write 12 into beta 10 to the power minus 2. Beta, I'll write again here so that you can understand. So finally, student, you can force, you can write beta 9. This is 9 into 10 to the power beta. This is what? You can say plus 3 plus 9 minus 6 beta. Into beta, this is, you can say 2 into 10 to the power minus 5. Then beta, this is what? You can say 100 by 2 minus beta. 100 by 12. You can take what's a further LCM here and do solve. Further, you can solve what's uh, maybe you got, I can say force value over here. That is what, what's a force value beta? How much will you get finally here? Uh, I can say Vachaji, for this question, maybe any data is not available. Further, you can solve Vachaji. This is my mean to see this. What's the approach of the question? Now, Vachaji, have a look next year. Oh, students, I can see this question already asked in J Advanced. Student, this question already asked in what, my dear? I can see J Advanced 2005. 2005. Right, my dear? Okay, velocity of particle varies with what? I can say position. Velocity of particle varies with position as shown in the below graph. Find the correct variation of acceleration with position. Student, it's not tough at all. There are many ways, but I'll not waste your time. Right? I'll give you short trick because for this point only looking growth of the student for short interval of time with less effort, more output beta. Have a look beta G. This once beta, you can talk about this graph, which is student VX graph is mentioned for us. It's class question. Student, I did multiple time here. Student, it's a VX graph, right? You can tell easily what's the slope of this graph. Student, you can tell easily slope is negative. Student, you remember, if you remember in the classroom, I gave you there is one box formula. And also I committed, definitely will get one question in J. Now, students, I can say already got A as a function of G. What you can write? A is equals to beta dV by dt. If students A as a function of x, then what you can say A is equals to V dV by dx. Right, my dear? Okay, so this is what? Slope is negative. So what is slope? dV by dx. Students, here you will get dV by dx is what? Negative. What implies beta? Because acceleration we can write v into dv by dx. And this what? Students, you can write over here acceleration we are getting negative. A is what we are getting negative, right? No beta. You can see everywhere here. No any option possible at all. This is also positive. This one also positive. This one also positive. This is we have only choice to answer the questions. Just imagine how easy. This question already asking about J advanced 2005 beta. This question already asking what J advanced 2005 beta. So what's your answer, Vijay? This is students. Options Bombay is correct answer for this question. Option Bombay is what, my dear? Correct answer for this question. Yes, beta. Now have a look next year. Beta, what is the next question? Yes, beta. This is the questions here. I can see this question again not tough. It's literally easy. But there is a concept which you can keep in your mind because they didn't mention any statement as help. But I see it in the classroom. If you are getting questions on RC circuit, then you can take consideration as a what, my dear? You can take consideration for steady state. Time is what? Infinite. If time is infinite, or you can say better time will be infinite, no matter what you can say for this condition. That is, I can say culprit for this question. Student, that is, I can say culprit for this question. What, my dear? You can write over here. That is, if time is infinite, then you can say student capacitor acts as an acts as a open circuit. Yes, beta. This is the point for these questions. Simply, beta, I can easily write here, right? So what's the point, beta? Ji? Just go through this. You have to you have to just redraw the circuit. So now, students, have a look here. This is remains battery 10 volt, my dear. This is student 6 ohm. This is remains 8 ohm beta. This is ampere. We wish to find what is the current passes through ampere. That is, I can say question beta. This is 4 ohm beta. This is 8 ohm, my dear. No, this is open circuit. So no need to just take consideration of this beta. This is there. I can. This is the line. There is line. What capacity is attached. Now, students, just they can go through this all basics. What, my dear? This is 8. This is 8. This is 4. Hello, my dear. This is 8 student. This is 6. This is 10. But I know these two are in parallel. So what you can say? 8 and 8 becomes 4. 8 and 8 beta. What you can say? 4 only. Okay, 4 plus 4 beta in series. So you can entire student just say this is what 8. This is what 8. So I'll make one more diagram here for better understanding. This is my dear 6. This is 8. This is students, I can say. Student, I'll repeat here. 8 and 8, 4, both are in parallel beta. Simple student, you can apply the formula. Student, you can apply the formula R1 into R2. I can't understand. Okay, listen carefully, beta. You can understand, beta ji. You can understand, my dear. Listen carefully. R1 into R2 plus R. Beta, no, these two are in parallel. These two are in which class you are? In which class you are? 11th, 12th. Because this question is from 12th class. R1, R2, beta. So this is, beta, I can apply the formula. What you will get? This entire is 4. Then this 4 and this 4, both are what, beta? You can see in parallel. 4 plus 4, 8. So this is, students, you can connect over here. This is 8, my dear. This is 8. And 8, again, which you can say this 8 and this 8 in parallel. So what becomes 4? And this is what? 6. So what's the R equivalent, my dear? R equivalent, you can write here. This is 10 O. So what is I beta? You can write I is what? V upon R equivalent. So V is what? 10 upon 10. But what you can say, this is 1 ampere. But you can't answer 1 ampere. It's a wrong answer. Oh, 11th. Okay. Then just wait for 11th class student. Student just wait for 11th class concept. Right. Okay, beta. So now student, for this condition, beta, what is correct? We'll get 1 ampere. Now, students, you can say this is what remains 1 ampere. Current passing through here. Beta, what we can see? 1 ampere, right? So, beta, I can say for this condition, these two are identical resistor. Beta, this is also 8 ohm. This is also 8 ohm. So, current will divide equally, student. This is 1 ohm. This is 1 ohm. So, here current, student, you can say this is zero point 0.5 ampere. So this is again zero point 0.5 ampere student. So question asked by this. So there is a meter. So what is current passes through a meter? So answer not 1 ohm. Your answer option C student. Right? Have a look next. Now beta. So what's these questions? Okay. Student, this question from 11th class. This question from what student? I can see for 11th class. So what question student? A particle attached to an ideal string is projected from position B. Particle, this is initial position, my dear. This is what I can see initial position. Okay. Lowest positions at and beta full stop. At position A, tension in the string becomes zero. Find speed in a string at B. So this question from 11th class, work power energy, right? So now I'm going to solve this question. Student, now I'm going to solve these questions. Simple student, I'll make a VD here, then I'll make a VD over here. So first student, I'll make this is FVD of particle at point A. Now since you can see logically here, this angle is 90. So how much this angle beta? This is 30 degree. This is 120 here. So here is good. You can write as a this question's explanation like this. If you remember, like a discussion in the classroom, arc B to C. So somewhere students that I'm considering over here. Particle is here, right? So particle moving from here. Let us suppose I'm calling VA. Student, this angle is known for us. This is 30 degree. Mass acting in this direction, which is equals to mg, right? Now, student, this is 30 degree. So you can see this is 90. So what student you can write this angle must shoot is equals to 60 degree. Now, beta, I'll use the questions here. Beta, mg what? Tension students, tension always acts along the string. Right, beta? So this is, you can take component. So tension also in this direction and mg cos 60. Beta, just I'll make a video. So you can say tension also in same direction. And this is what, my dear? Mg cos of 60. If any particle moving on a circular path, then student, what you can say? Centrifugal force always acting away from the center, which is equals to m into VA square by what beta? R. Simple, yeah. MV square by R. Now beta just equate these forces, right? Along tangential points, you can say. So beta you can write T plus mg cos 60 degree is equals to m VA square by R. Now beta tension zero mentioned in the question itself. Then bacha, what you can say, mass beta also cancel each other. So simply beta, you can write VA is because answer beta in terms of L they mentioned here means they have taken R is equals to L, but I'm considering R here only. So VA students you can write this is GR by 2. So we got VA, but we wish to find VB. It's very easy. So you can take a entire in step 1. Now, students, I'll discuss step 2 part of these questions, right? So in step 2, student, what I can say, student, I'll apply from here to here what? Conservation of mechanical energy. And it's a very common song. I hope all of you remember. You have to sing this song now. What is student? Kinetic energy initial plus potential energy initial is equals to kinetic energy final plus what, my dear? Potential energy final. Simple here. What is initial kinetic energy? Half mvv square. Which v is to find? Half m beta g vv square plus particle is at origin. So there is no potential energy at all. Now, students, you can say kinetic energy final S half m beta va whole square, right? Okay. Plus beta g. What is the potential energy? Here I'm writing beta plus. This is what beta mgr into 1 plus cos theta. You can see how it came. It's very easy beta. You understand? No particle basically this much height it traveled. This much height. And what is this height beta? I'm considering here r. So you can take this component and this is what 60 degree because this is 30. So this is 60. You can take beta r cos 60 basically this height. This is r cos 60 degree. Simple bacha. Now here is less space, so I'll solve this question over here. Step 2 beta calculation. Students, here I'll solve bacha. Step 2 calculations. Right, my dear? Okay, listen here. Stay in the meeting, just listen. Now bacha, this is half m v square is equals to beta g half m va square plus beta. This is mgr 1 plus cos 60, you can see 1 by 2. This is 3 by 2 beta. You can see this entire m cancel each other. We wish to find dv beta. You can see 2 cancel and 2 multiply over there. 2 from here cancel with and 2 multiply over here. Then you can see VV square. VA square beta, this is what you can write. GL means GR by 2. This is beta, you can see GR by 2 plus 2GR into beta 3 by 2. This is cancel beta G. So what is supposed to write finally? This is V square. What, my dear? V square is equals to beta. This is GR by 2, right? Then no need to just, I can see, just take beta as usual, same only. This is beta, you can see 2 only. So this 3 to the 6, 6 plus 7. This is what you can write 7GR by 2. But R student already I see R I have taken L. So VV beta, this is root of 7 GL by 2. VB is what beta? The root of 7 GL by 2. So student, any option is there here? Yes, beta. Options D is correct answer for this question. Options D is what, my dear? Correct answer for this question. Okay. Now student, have a look next here. Have a look next. What was the next question here? Beta Z, radius of what, my dear? Radius of soft bubble is change from what 7 centimeter to 14 centimeter. You can see beta initial radius of soft bubble is 7. Final is what 14. Then the work done in this process in microjoule is already work done mentioned 15,000 minus x. Find x. So you need to take for this calculation of question pi 22 by 7 and sigma. You can know it's not sigma, it's a surface tension is mentioned. That is what beta? Surface tension students, you can take that is 0.04 Newton. 0 point, what was it? 0 point, this is, beta, you can say 0.04 Newton per meter. Okay, stay beta in the meeting only here. Then, beta, what I can say as a solution. Have a look. So, I hope all of you remember surface tension. Student, surface tension, you can write force per unit length. Or you can say this is surface energy or energy per unit what beta? You can say area. Simple. Student, I'll use this principle, my dear. Student, I'll use this principle. So, student, here I can say we wish to find work done. So, what is work done here? Work done is nothing but this is what change in potential energy or energy you can say. So, here student, you need to find this is U final minus U initial, right? And energy is what? Surface tension into area. Students, you can say, my dear, energy is equals to surface tension into area beta. Okay, so you can write beta G. Work done, surface tension beta. This is what you can say sigma, and it's a beta a soap bubble. So what is the area? 4 pi r square. Surface tension beta. I know there is one point. It's a bubble. It's not a drop. Then you can take 2t. Be careful, beta. Be careful, beta. This is two bacha, but it's a soap bubble. It's not. I can say bacha like beta a drop. So you can take beta surface tension about 2 sigma. You can take beta 4 pi common. Then bacha you can say R2 or you can say R final minus beta you can say R initial whole square. Okay, beta G. So this is work done beta 2 into sigma beta how much? 0.04 into beta 4 into beta. This is 22. This is 2 sigma is 22 by 7. R2 beta, this is 14 centimeter here. You can see this is 196 10 to the power minus 4. And 7 7 are 49. 7 7 are 49 into beta 10 to the power minus 4. Now we are just do with us further calculation here. So, bacha, you can say work done is equals to this is what? You can say 0.08. Now, beta, this is you can say into 4, 22 by 7, 196 minus beta 49 into 10 to the power minus 4. Beta, how much will come here? Just say bacha party. Further, bacha, this is what you can see 0.32. 0.32 beta, this is 22 by 7. 6 beta 9, this is 7 which 9, 8, 8 minus 4, 4 which is this is, you can see 147 into beta 10 to the power minus 4. Further solve beta, you will get this is work done 14750. Beta, you will get further here 14750. 14784 बच्चा जी in joule only. Now this work done we have to equate this with that. Then we'll get x. So bachcha, you can write over here work done is what 14784 and work done already mentioned in the question student, right? Work done beta already mentioned in the question student, right? This is also in microjoule. This is also in microjoule bachcha everywhere. So this is what beta 15,000 minus x is equals to 14784. Just with a further do calculation here, x you will get this is 216. Any option is there, my dear? Yes, options number Canada is correct answer. Option number what is student? Canada is correct answer. Now let us have a look next year. Betaji, this is I can say question number 7 for 24th January second shift. For a uniform cylinder of length L and radius R, the moment of inertia is I1. Now, for the similar situation, but length is L by 2, radius is R by 2. Moment of inertia is I2. Then find I1 by I2. Okay. But here I'll do. There are two diagrams. So we'll go slow here. This is students. We can take. This is case one. Beta, so case one, what you can say, this is the cylinder. What dear? This is what my dear cylinder. So you can take this one, this cylinder is radius R and this length is what L. So we have to find I1. Now beta, you will see from this side beta, this is cross section. So what you can say, this is moment of inertia of a disk. So I hope all of you remember moment of inertia of a disk about diameter. That is what Vichaji? This is what Vichaji? Tell. This is what basically mr square by 4. What my dear? Mr square by 4. So student, here I'm writing expression of I1 is what beta from this side. You can say mr square by 4. Then beta, this is a rod. What is moment of inertia of rod at midpoint, my dear? What is the moment of inertia of rod beta midpoint? Tell. This is ml square by 12 beta. You can write, my dear, ml square by 12. But you don't know what is the value of mass. You don't know, dear, what is the value of mass, right? But we can find mass easily, bacha. You can use beta basic principle. Mass is what beta? You can say density into volume, right? So this is density remains fixed. What is volume, bacha? Per cylinder, pi r square h. What was the pi r square h? So you can say pi r square L. This is the mass value beta g, right? So this value beta I can fit over there. So I will students, what you will get rho pi r square L into r square upon beta g 4 plus rho pi r square into beta g L into beta g L square upon beta what you can say this is what 12. So I'll take common here rho pi r square L, right? So I will beta what will get rho pi r square L into beta what you can see this is r square by 4 r square by 4 plus beta this is you can say L square by 12 L square by 12. Similarly beta I'll find I2 as well. So for getting I2 beta for I2 there is a different situation my dear. No, what say the questions you can say this is case 2. There is a cylindrical rod, right my dear, and this radius is what r by 2. This length is also what L by 2. Yes, beta, L by 2. Simply beta, we can find again here moment of inertia. You can write this is I2. This is what is called I2. I2 is what beta? Again, you can say M R square. You can take this is M, this I'm calling beta M prime. M R square by beta 4 plus beta. You can say M prime L square by 12. So beta, first we can find what is the M prime. This is what rho pi and what is r? You can say r square by 4 into beta L by 2. So M prime what will get? Rho pi r square L upon beta is 8. This value beta we can feed over here. And r is what? R by 2. L is what? L by 2. Also we take in consideration beta. I2 beta M dash rho pi. Beta this already we have taken it. So no need to replace over here everything, anything. R square L. Upon beta what you can say 8. This is beta. You can say R square by beta what you can say 16. 4 for the 16. R by 2 na. This is R by 2 beta. So what you can say 4 and 4 16 beta party plus beta. This is the immense my dear rho pi r square L into beta what L square by beta. This is 12 into 8 into 8. No, 12 into 8 into 4. 12 from here, 8 from here, and this is L by 2. Then you can write by 4 only. Now, beta, again, you can take common here. What? Rho pi r square L upon beta 32. You can get here, and this is 28. This is 4 bacha party. So here you will get beta only r square by 4. Here beta, what you will get? L square by 12. L square by 12. But let us suppose you can say this equation is A, my dear, this is B. So you can find I1 by I2. So what which you can say entire terms is cancelled. Rho I square L by beta G into this is R square by 4 plus student L square by 12 upon beta. This is what? This L rho I R square L by 32 into beta R square by 4 plus L square by 12. You can see beta entire times cancel with each. So this is what coming 32. This is what coming my dear. This is what coming my dear. This is what 32. This is what 32 beta. Literally, it's a lengthy question only calculation by, but it's not, I can say, tough question. Doable only beta. It's doable my dear only. You can do easily the paper all as well. So what's the answer? Options A is correct answer. Option A is what is student? You can say correct answer. Now, what's move next questions here. Again, which I can say this question from classroom only. But this question from classroom only, I said, I can see this question multiple time I saw in the classroom, right? During GS also, number class also as well. So, this to solve this question, there is a little concept required, which is known as what I can say folding symmetry, which is what is known as folding symmetry. So I'll apply concept over here to solve this question. This is what, my dear? This is, you can say, folding symmetry. Folding symmetry. Beta, what is the meaning of this concept here? Beta, you can just fold from here, right? First, beta, you have to redraw the circuit. So if you will redraw beta, then you will get like this. This is beta. There is no change to A to B, across which if you are finding there is no change here. This is remain same. Beta, you can just take look like this. Student, you can take look like this. Then beta z. This is R only. There is one more R beta z, right? Now, students, you can say this is the condition. Yes, beta. Now you can say this R and R beta series only R plus R. What you can say 2R. 2R and R. What was in parallel? 2R by 3. So, student, entire you can say entire student you can replace by what? This is 2R by 3, right? Beta z. Okay. Here, students, again, you can apply same thing. This is what my warrior. Again, bacha, this is entire things. You can say this is what 2R by 3. So this is a 2R by 3, and this is R and R. Beta, what in series? So what students I can say? This is just student just solve further here. I'll solve one and just beta I'll apply everything. So student, I'm just solving this entire part. Right, this is what beta? This is 2R by 3 and in series 2R. So beta, I'll write R equivalent in series beta directly here. So 2R by 3 plus 2R. 3 to the 6 beta. This is, you can say 8R by 3. So you need to make again one more diagram here. This is 8R by 3. Now beta, this is R and R. Beta, I'm talking about this R and R in 2R only. This is 2R beta G, and this is what, my dear, 8R by 3. This is remains beta 8R by 3. And this is what beta you can see 2R. 8R by 3 and 8R by 3 beta in parallel. And finally, you can solve it. These all in parallel. So 1 upon R equivalent. 1 upon, you can say beta 8R by 3 plus again beta 3 by 8R plus 1 by 2R beta G. Yeah, so just take LCM beta. This is beta 8 only. So this is 3 plus 3 plus beta. You can say 4 upon beta is 8R. So what will you get here? 4 plus 3, 7 plus 3, 11. Right beta? No, there is something wrong here. There is something wrong with here. There is something wrong with Delhi. Further case here, R equivalent will get 4 by 5R. Hence, option number Bombay is correct. Hence, beta option number Bombay is correct. Now, let's have a look next question here. So, what question says? The next bit is two identical loops. Two identical loops are placed coaxially. Two identical loops are placed coaxially. Yes, beta. The two identical loops are placed coaxially, beta, as shown. Radius of both loops is R. Find magnetic field at O. Okay, we have to find magnetic field here. So that is in it, beta. No, for getting magnetic field, beta, what you can say, students, first doing before to start calculation of these questions, in your mind, you have to keep this formula. Magnetic field on the axis of current carrying ring. This is what, my dear? Mu naught into I R square upon twice of R square plus X square 3 by 2. Right, beta J? Okay. You know, beta, due to this current, just you can understand here, this is. Beta, this will what? Direction of magnetic field, beta. This is wrong. No. Beta, you can think like that. So beta, this will goes in what? In right. And this is what, beta? Goes in left. Four, right, beta. So here you can see magnetic field at point P. What, beta? Mu naught. No, bacha, just find one thing here. Because this is R and this is R. You know, radius remains R only. So what's the distance between here to here? This is what, my dear? You can say root 2R. This is what we tell you root 2R. So, bacha, I can say this will go through the further calculations here. Right, further. So, beta, just we can apply the things here for the question itself. So, bacha, this RR remains same here. There is no any contribution of this, what I wrote to R. Mu naught into beta I. This is R square. Twice beta G. R and R beta. This also R, this also R beta. So, you can see this is 2R whole square to the power 3 by 2. I hope you understand my point. Then what you can say, this is mu naught I. And I is what beta? I'm writing for P beta. So this is, you can write 4I into R square upon beta 2 into, this is what? 2 R square to the power 3 by 2. So R square simply you can write, this is R cube, and 2 to the power 3 by 2 beta. What you can say? It's a root 8, which is equals to 2 root 2. Now, students, you can say this 2 and this 2 beta finish 4. This RQ finish. So what you will get, my dear? Mu naught into I by root 2R towards right direction. Towards right, or you can say towards P. So answer definitely should either this or this. These two are not possible. Now, student, here you have to calculate magnetic field at Q. So this is what, my dear? Mu naught into I. I remains I only. This is R square. Twice of beta, again you can say 2R whole square 3 by 2. So what, my dear? Mu naught into I R square upon beta G. What you can say? This is remains 2 beta. 2 to the means you can say 2 to the power q and R square. R cube basically. So students, you can write 2 root 2, my dear, into what beta? You can say R cube. RQ cancel. So beta, what you will get? This is mu naught into I, mu naught into I. My what beta is 4 root 2R. Simple bacha. You know, this is more with respect to this. Beta, just subtract this two beta. This just subtract beta these two here. Magnetic field bacha is right. So you can see beta magnetic field P minus P. So beta for magnetic field net at point O. This is what, my dear? BP minus BQ. So BP is what beta? You can take mu naught into I by R common beta G. 1 by root 2 minus 1 by 4 root 2. The take LCM beta party. 4 root 2 will get. So this is mu naught into I beta R. And what's LCM student? As I said, 4 root 2. So this is, students, you can say 4 minus 1. So what, my dear? 3 mu naught into I upon beta 4 root 2r. Any option is there, which is? Yes, we have option. That is options number A. Options number A. But I can see it says strong recommendation. Those candidates will go to write coming evenings. It's a light questions of I can say but identity. We will get pattern of these questions. Now students have a look next questions here. So now beta I can say the correct truth table for a given logic circuit is. So in this question, you can do by heat and trial, right? You can take beta data and just go through this. Let us suppose beta, you can take this is A is equals to 0. So this is, students, again you can see 0. This is 0. So here we'll get 0. This is 0 beta I have taken and B I have taken 0. So this is 0. Entire 0 beta, this is 0, this is remain 0. So entire zero only. So we are getting what output one. So I can say option first not possible at all. Option first not possible at all. Okay, my dear. Now options B you can take consideration. What was it? A0, B00. Yes, correct. Now, bacha, you can see A0 and B0. Again, beta. This is you can see there is possibility. This is correct. A1, B0. Then one. How possible? Again, wrong, beta. B also not possible. Then bacha, if we go for, I can say options number C. A0, B0. You can say bacha, dot product 0 only. A1, B1. Then dot product 1 only beta. So again, you can say C is not possible. So what's options? That is options number D is correct answer for you. That is options number D beta, correct answer. Now beta, have a look at next questions here. So what is good? Question number 11 says, they're telling us distance between an object and its image formed by a lens is what? 30 centimeter. Okay, you can see this is V minus U is equals to what? 30 centimeter. With magnifications 3 means n is equals to 3. Find the focal length of lens. Okay, students, you can do these questions here. But maintain patience in the classroom, or I can say in the during tests if you are writing exam. Then bacha, you can say this is first relation there. You can use V minus U is equals to 30. First beta. Students, you can use over here, yeah, magnification V by U. You know, it's positive for lens. So now magnification beta, this is 3. So this is V by U. So you can say V is equals to 3U. Beta, you can put over there. So this is what is friends 3U minus U is equal to 30 beta. So 2U is equals to 30. So U beta will get 15 meter per second. If U 15, then V is what beta is 45. If U is 15 beta, then V is beta what will get 45, right? So beta here we'll take positive sign here. So you can say U is what for calculation beta minus 45 beta minus 15, and this is V beta what you can say this is also beta minus 45, right? Then the subtract this will give 30 also. So now beta party this condition, this is what I can say beta which you will get, that is U minus V. That's party. This will go through this here. How can we solve further? Uh, Beta, this is step one. I can say step two. Beta, apply a Lewis formula. 1 by V minus 1 by U is equals to 1 by F. 1 by V beta, how much? Minus 45. Minus minus plus beta. 1 by 15. 1 by F beta is just 45 beta. What you can say? LCM remains 45 only. So this is a beta minus 1 plus beta 3 is equals to beta 1 by F. Beta this is you can say 2 by 45 is equals to 1 by F beta. So F you will get 22.5 centimeter. Options A is correct. Options A is correct, right? Okay, beta, have a look next questions here. I can say questions number 11. Now, beta, two nucleons reactions are given below. Okay. Here we have to just arrange simple. So here we have to just arrange here. Beta, here energy is less, so we have to provide energy of this particle. Energy is what? Here more bacha. So I can say this particle has a maximum, I can say stability. So you can write He24. Then bacha, these two are identical. Then beta, what you can say, this is He25. Then bacha, He2, and this is 3. So this is very question is 20 in statement. Now beta, have a look next. Question number 13. What was the question number 30? Student, yesterday I already wrote here. Student, already I wrote here, right? Student, this is the study night during live class. During live class session yesterday, I declared. Anyone go and check. Yesterday night, I can say 23rd, second shift. If I was solving, I said this is about this question. Someone asked, sir, what I have to do for second shift? And unfortunately, student, this question is giving second shift only. So, because sir, physics point, it's a prediction. Always, I can say beta, fruitful only. So, student, what is the things here? No, student, here I'll use beta, what I can say, concept of galvanometer to ammeter, G to A conversion beta. No, it's very common here. No, this is, let us suppose, current coming from here only. I'll make one more diagram beta here so that you can easily understand here. This is student sun. This is my dear galvanometer, right? So current coming from here. So this current little bit will go over here. Let us suppose you can say I1. So what is current over here? The final year. So you can say I minus I1. Beta, what is the tendencies to current will flow till now? That is what you can say potential must be equal. Just simple beta, you can equate beta shunt potential difference equals to what? Potential difference on resistor. That's all. So beta, this is, you can write, I'm writing potential drop on galvanometer. IG RG is equals to beta is equals to, my dear, I minus Ig into beta g shunt. Simple. Ig beta mentioned in the questions here. What's the question? I'll read once. A galvanometer of a 100 ohm resistor. Friends, we can say Rg is mentioned 100 ohm. Give a full scale deflection. So, students, IG also mentioned here. This is 1 milliampere, right? Find the value of shunt resistance. If you can see current, that is I value, is also mentioned, my dear, 4 milliampere. But I can feed our entire values. So, IG is what beta is 100. RG is, sorry. IG beta 1 milliampere. RG beta 100 here. So 1 into 10 to the power minus 3. Now beta, Ig is what you can say? I is 4 milliamperes. I can say 4 minus 1. Beta, I'll take out here like milli. 10 to the power minus 3 into beta the shunt. So this is, you can say, cancel, my dear. So you will get 100 by 3 is equals to shunt. 100 by 3 is equals to beta. So this is the answer for the question. In ohm, you're supposed to write. So you can say options Bombay is correct answer. Student, option Bombay is correct answer. Now beta, have a look next question. This question is from 12th class. Now, Bitaji. So what questions next? No, this is the same question, student. Yesterday they repeated in JEE mains 23rd second shift. This question again asked in second shift in 24th beta. So before you will go to write exam, be remember do PYQs and at least you have to do those questions which is in the market. Student, like we are getting like memory based questions. So have a look student question first in meter waves shown in diagram. When X ohm of resistor is connected in parallel to 3 ohm, null point shift by change in meter, then find X. Easily you can do beta. right? So let us suppose, students, you can say initially this is x. No, what's entire length beta? That is 100. So you can say, my dear, this is 100 minus x. Okay, student, apply the formula here. Students, apply formula. This is R1 upon L1 is equals to R2 upon L2 beta g. R1 is what? 2. L1 beta how much? This is x. R2 beta is 3. This is what? 100 minus x beta. Just do cross multiply. Twice into 100 minus x is equals to 3x beta. So 200 is equals to 5x. X student, you will get 40, right? This is, students, you can say case 1, or you can also say step 1 for this question. This is what, my dear, step 1 for this question. Now in step 2, what says? First, I'll do a diagram beta. So you can say this is 2, there is no changes. This is 3 ohm beta, right? And this is, you can say, I'm making a normal, not exactly same, just for understanding beta. This I'm doing here as a rough diagram. Now beta, I can say this is what? Battery. What's in the questions? Along with this 3, this is 2. I'm connecting another unknown resistor. Let us suppose this is R. They mention X ohm. I'm considering R. Remains same only beta. Now, what's in the questions? If you will connect, or you can say if you connect R parallel to this, then there is what? X will shift toward this, towards right. So then we have to find value of R. It's a pretty easy question, students. I already said this question came in yesterday, second shift as fail. So what beta? This is just apply same formula which you applied previously. R1 upon L1 is equals to R2 upon L2. Simple beta. Now, beta, what you can say? R1 upon L1. So R2 upon L2. R1 beta, this is remains same here, no change. 2. And what's L1 beta? It's a shift by 10. So you can say beta X plus 10. R2 beta is what you can write? R2 just beta, you can apply here. That if we have a two resistor in parallel, so what you can see is you can replace R1 into R2 upon beta g, R1 plus R2. Simple beta. So you can say this is R into 3 upon beta g, 3 plus R into L2 beta, what we can say? 100 minus X plus 10 beta. Simple, yeah. Just beta. Further, you can solve beta g. So you can say this is step 3 beta. It's a calculation of these questions. I can say from here. Now beta, this is 2 upon x is what? 40. We already found. So you can write 2 upon 50. This is what, my dear? 3r upon 3r plus x. Am I right? 3r plus x. It's wrong. You're not right. This is what, dear? 3 plus r. Beta, you can say 100. X is what, beta? 40 plus 10, 50. So you can say this is what? Minus 50 beta g. So just do beta further calculations, my dear. This is, you can say 2 upon 50 is equals to 3r beta. 3 plus r. Beta, this is remains 50 here. 100 minus 50 beta. 50 only. You can see this is cancel each other. So just do cross multiply. Do cross multiply. So this is what? Twice into beta. 3 plus r is equals to 3r beta. So you can see 6 plus 2r is equals to 3r. 6 is equals to r beta. So what's your answer, beta? Or you can say x is equals to 6 ohm, because in the paper mentioned x beta g. So your answer is what? Option C is correct. Students, your option C is correct, my dear. Right. Have a look, beta. This is question number 14. Now, beta, this is question number 11, 15 beta g. A cubical block of a density 600 kilogram per meter cube is floating in a liquid. Okay. So density of liquid is what, my dear? 900 beta, that is kilogram per meter cube. The height, what is student? The height of the cube immersed in a liquid. We have to find. Simple. Okay. So beta ji, for this condition, what can we apply? It's not again beta, I can set up question. It's pretty easy questions. So, bacha ji, a cubical block. Just take consideration like this. This is no beta. Physics is the language of FBD, my dear. So you can say there is a floating body, or you can say cubical body, right? I don't know what's how much height. You can say this much height. This I'm considering here one side of a cube. Keep in mind, beta. Student, here I'm considering one side of cube. Now, which so you can see this is the condition, beta. Right. I don't know what is this. What the height? Height. Let us suppose I'm calling beta. This height is what? H, which is inside. What's the question? Height of the cube emerged in a liquid, right? Okay. So beta, simple we can apply here. When system is remains in plotted conditions, so you can say equilibrium. If system is in equilibrium, beta, then what you can say? This is beta buoyancy force is equals to simple beta. I can say mg. And what's the buoyancy force? Buoyancy force beta. Buoyancy is what? Rho vc. So beta, this is you can write rho vc is equals to means I'm writing here sigma v in g. V and v cancel. So sigma beta, that is what means in density of body, which is equals to 600. And this is what? Side L cube, you can say with the simple. This is what? Side L cube. Side beta mentioned here, 10 centimeter. L student mentioned in this question, which is equals to 10 centimeter beta. Okay, very nice. Which here, volume is what? You can see area into length. Volume beta, what you can see, area into length. So this is what beta 900, and this is area L square, and this is H. You can see L square and L square cancel. So H student, what you will get? 600 into zero point 0.1. Beta, it's a centimeter here. Upon beta 900 here. This is cancel. 6 by 3. 6 by 9 into zero point 0.3 here. So you can say H is what? 2 by 3 means 2 by 30 you can say which maybe I'm correct. 1 by 15 beta g you can say meter. 1 meter beta what you can say? 100 centimeter. Answer beta in 100. So you can convert beta g. 100 by 15 here. So we'll get 6.67 centimeter. 6.67 meter. What I can say centimeter, which is option number A. Now students, have a look next questions here. What has been, again, yesterday, those boy asked, sir, any prediction on Werner caliper? Yes. No, beta, because they, I can say, since, I can see, beta, yesterday, till I can see 23rd of January, they didn't ask any questions. So there is a probability to ask Werner caliper. Beta, Werner caliper literally, I can say it's experimental setup. So maximum time they try to create a question based on experiment, right, my dear? Okay, so have a look, student. What questions is one time I'll read with a right. In a vernier caliper, 50 vernier scale division coincide with 48 main scale division, right, my dear? Okay, if one main scale division is 1 mm, then list count of the measurement is simple. It's not a tough at all. Physics is very easy. You can feel at physics point because here explanation bottom to earth. Now, beta, have a look at the questions here. What's the questions? The question, let us suppose you can understand like this. This is students vernier caliper. This is students I'm just plotting over here. It's a main scale. It's a what? Main scale. So this is student, let us suppose I'm calling 0. Just consideration here. This is I'm calling 1 centimeter. So you can see this is 1, 2, 3, 4, 5. 1, 2, 3, 4. This is 5, 6, 7, 8, 9, and 10. This is with main scale, which I told beta. This is I can say main scale. MS what impress representing with main scale. Now Students, what is the questions? I wanted to explain first theory because it's the questions you will get. Not at all, maybe you will get this question. So you have to learn concept, then you will get question, my dear. Betaji, this is the main scale. Student, what is the conditions here, which I can tell you? This is beta, you can say vernier scale, and this is a 10th division of vernier scale, right, my dear? This is, you can say, 10th division of vernier scale. You can write 1, 2, 3, 4, 5, 6, 7, 8, and 10. So what is the least count beta formula? What is the student, I can say, formula of least count? What was it? Length of student, length of one mean scale division minus beta z, you can write length of one vernier scale division. That is a primary formula beta, which you can keep in mind. Always applicable everywhere. Length of one mean scale division minus length of one vernier scale division. That's all. So now, beta, what's the question? Now we'll do the questions here only. What's in the question? 50 vernier scale division. What is student? 50 vernier scale division coincide with 48. Here, beta, what I can say? 10 vernier scale division is what? Coincide with ninth. Then you will get 1 MSG. But student, for getting least count, we have to find length of 1 MSG minus length of 1 VSG. Student, in this question, length of 1 MSG mentioned. Student, in this question, length of 1 MSD is mentioned, right? So we have to find length of 1 VSD. Student, you can find VSD according to question, my dear. They mention 50 vernier scale. So you can write there 50 vernier scale division is equals to what, student? 48 main scale division. Student, 50 vernier scale division is equals to what? 48 main scale division. That is the point. Now, students, you can write one vernier scale division is what, my dear? 48 by 50 main scale division. Bacha, we got MST, VST we got with a MST mentioned in the questions. Now, student, I can say this is the formula part theory in step one. Step two, beta, again I'm writing, I can say formula is here. List count. What, my dear? List count. You can say 1 MSD minus 1 VSD beta. So MSG is beta, you can just leave it. MSG only. VSG we found. How much beta? 48 by 50 student MSG. Just beta, just do simplification. You can say 50 minus 48, 2 beta G. 2 by 50 MSG. No, student, 1 MSG is mentioned. Student, 1 MSG is mentioned. Beta, what are it? 1 mm, 1 mm beta, right? Answer in centimeter here. So you can say 1 MSG is what? 10 to the power minus 1 centimeter beta. So you can say this is what? 2 upon 50 into beta. This is what? You can see what's 1 upon 10 here. 1 mm, no, because 1 centimeter is equals to beta. This is 10 mm. So 1 mm, what you can write? 1 upon 10 centimeter. Simple. What's the big deal, beta G? Okay, fine. Now, bacha, what you can say? So this is, you will get 2 upon 500. So this is 1 upon 125. Beta 0.04 centimeter you will get, my dear. Right? Hence, options A is correct. It's a, I can say, strong recommendation. Those candidate will go to write JEE mean for coming days. We remember this concept. Will help you a lot. Will help you a lot. Now, bacha, have a look next questions here. What's the question? Stopping potential V naught is mentioned. That is 3.3. volt. For wavelength, you can say lambda 1. If wavelength is double, if wavelength is double, the stopping potential becomes zero point 0.7. Find wavelength means we have to find beta wavelength only. Find what beta g? I can say wavelength. Simple, yeah. You can use Einstein equations. Students, you have to use Einstein equation. What? Energy maximum is equals to energy minus beta the work function. E max is what beta? EV naught for the case of you can say work function. So this is mentioned bacha party. How much? You can write 3.2 electron volt beta. I'm writing bacha here only here. E max beta. This is nothing but EV naught. EV naught beta G. So this is 3.2 electron volt beta. Okay. Now beta, this is E. E is you can write beta. E use SC by lambda minus work function. Say equation number one beta G. Say equation number one, my dear. Now what's the beta next? Your stopping potential 0.7 electron volt. Students, you can write in step one. Now, student, step two here. 0.7 electron volt. Hc by lambda minus beta is the work function. Say equation number second. Simple beta. Just subtract these two here. Equation number first and second. Minus beta. This is what you can see minus here, and this is what minus minus plus minus minus plus. So further beta, you can just solve here. You will get answer of these questions, right? Hc by lambda, bacha. Or you can also do minus. Maybe I will not get right. Right. This is cancelled. No, wrong beta. Just divide these two. Beta, just divide these two here and further you can solve the Chapati, right? So lambda you will get lambda further you can solve the Chapati. Maybe you will get like 2.5 like that, right? So just go through beta calculation here. It's a calculation, my dear. Just divide these two, you will get answer. Now, students, have a look next question here. Question number 18. So, what's question says, student? The object and image distances from lens says are recorded by students as U and V. Okay, I can say this is experiment again, which is done by students. Student already, I can say, means those are performing this experiment in the form of UNV. I can see noted few data P1, P2, P3, and beta what we can see P4, right? So students for this condition, just we'll go through what is the main point. Student in this question mention power of lens is what? Beta G 5G. Power of lens beta. What you can see, this is basically 5G. Okay. Then bacha party, just we'll go through this. What you can say for this condition. Beta, this is, yeah, I can see for this question, beta, this is true here. We have to just subtract beta because what this mentioned here, wavelength. Wavelength is double here. Wavelength is double beta. That is true, what I said. I'll write one more here. The 3.2 electron volt is equals to Hc by lambda minus work function zero point 0.7 electron volt beta. This is Hc by 2 lambda minus work function. Beta just I'll subtract Vachapati. So this is you can say cancel minus minus plus. Student, this is how much you will get here. 2.5 electron volt is equals to Sc by lambda. So lambda beta what we will get? Sc by 2.5 electron volt. So further you can solve here, we will get answer any of these questions, any of the options. My dear, this have a look this question here. Culture. So power is mentioned here. You know, this question again be a part of heat and trial, or you can say just do all the questions slowly, slowly, all the part beta. So what a student? Here first I'll find here power formula. I hope all of you remember. P is what? 1 by F. P is beta what? You can say 1 by F. So beta you can say bacha F in beta centimeter. So power beta how much? 5 is equals to 100 upon F charge. F what you will get? This is 20 centimeter, right? Now students, we have to just take data everyone. Let us suppose I'm considering P1. So P1 is what beta? Minus 30, and U is what? This is U student minus 30, U beta Z minus 30, and V I'm considering plus 60. I have taken P1. So now students, 1 by V minus 1 by U is equals to 1 by A beta. So you can write over here 1 by, this is what? You can say beta 60 minus minus plus 1 by 30. We are getting here. This is 1 by 20, means focal length 20 beta. So I can say P1 is correct. Student P1 is correct. Student P1 is correct. Right, my dear. Okay. Then student, I'll take P2. Students, I'll take P2. Beta G P2, what will you get? For P2 beta, you can say U is minus 30 beta and V is what? Plus 12. So student, again you can apply 1 upon F is what? 1 by plus 1 by V minus 1 by U. So 1 by 12 minus minus plus beta 1 by 30. So definitely you can say this is what? 360. So beta, this is, you can see 20 plus beta, this is cancel beta, this is 12. No, this will not come. P2 is not correct. P3 beta 2060 again not possible. This beta, I can say P4 you can check once. So P4 beta U is equals to minus 25 and V beta what you can say plus 100. Yes, this is coming. Yes, beta. 100 now? Yes, beta. 4. Coming, beta. I can say here again we are getting 1 upon F is what? 1 by 20. So your answer is that is P1 and P4. P1 and P4. Student, be patient in the paper hall. Student, be patient in the paper hall, beta. Right. Here I'm also, patiently I'm solving all the questions. So just listen carefully, beta. Thank you so much to be a part of in the night. Student, literally, I'm looking your dedication. I'm pretty happy. That's why BKs are also dedicating. No, it's at night timing, 4 o'clock. I can say 4:45, going to finish almost. Still, I'm with you because you also want to learn and also I want to help. So I'm very happy to see students your dedication, and it's literally very good time for study. 4 to 6 student, it's literally pretty good time. Student, if you are in 11th class, by tomorrow morning, tomorrow 12:30, tomorrow students, I can say 12:30, I'll start gravitation from zero level. I'll become live only beta. I'll become live only. I'll start gravitation. Students, tomorrow I'll start gravitation. That is, I can say, students, it's a request of 11th class students. Right. If you have any queries, you can connect me on Telegram as well. Physics point BK Sir, or write your concern in comment box, beta. I'll come back. I'll see and back to you. Now, beta, have a look next question, student. So this is, I can say, questions number 19. No, this is the same questions yesterday they asked, but in a different way. Exactly same questions, beta. Right. So what says student? Have a look one time questions. If K1 greater than K2, which order is equivalent for the three given configuration is correct? Okay. In which has a, I can say like more values of I can say capacitor with chapati. Right. So we'll go through this. Students, I can say yesterday I solved these questions. So this K1 I'll replace in two part. This K1 is what beta? I can see in what? This is the things which are in half half. So no beta, I'll just do a BT for C1 beta G. So this is beta, I'll take half. So this is my dear half, and again beta, I'll take this is K1, K1 only beta G. This is beta K1 and this again K1 here because it's a four part. I'm considering beta. You can take like that, my dear. This is half and this is half beta G, right? So students, for this condition, uh, this you can connect like this. You can connect like this, my dear. Okay, fine. So this is what beta you can say. Area also a by 2, my dear. Area also by a by 2 beta. This is also d by 2. Beta, this is very interesting, my dear. This is too much interesting, beta. Right. This is what beta I can say in the mention over here only. This is mentioned over here only, beta. This is K1 is greater than K2. K1 is what beta ji greater than K2, right? So student, this is I can tell beta K1, my dear. This is remains K1 बच्चा party. This is beta ji. This is my dear K2, and this is my dear K1, K2 as well. Now, student, entire is what? You can see this bacha feed the value K1, K2. You will get some answer from here, bacha, right? Most probably C1 is more. Most probably beta C1 is more. So I can say there is only one option, beta, right? Have a look, bacha. Next, bacha ji. Questions number 20. My student, questions number 20. Given the half-life of a radioactive sample. Okay, half-life is mentioned. This is three half-life to 45 days. After decay, 25% of what, my dear, sample is what? Remaining. Then find X. Okay, X we have to find. Student, I can say a little this question, na beta, like you can say in different way. Radioactivity is not much I can see in our syllabus. So, in fact, we have to solve the question, but we don't have a choice. Beta, just remember here this formula. This is law of radioactivity. This is thing. This thing I can say law. Yes, beta. This is n naught e to the power minus lambda t beta. This is law of radioactivity. This is what, my dear, law of radioactivity, right, beta? Okay. So here, students, you can say for what? Students, if time is zero, so what is initial nuclei? This is I'm considering in and not. What's in the question beta? This is 25%. This is what you can see 25%. So there is student we can think like that here. This is n naught by 4, which is n upon 2 to the power n. N upon beta what you can see 2 to the power n. So which you can say this condition. N beta how much? Just 2 square. N not beta z 2 square upon beta what n upon beta 2 to the power n here. So you will get what beta n is equals to 2. N is equals to 2. So finally beta you can write over here. X is what beta g? 2 into beta g 245. So X you will get beta 29. Wrong. 490 days. This is what beta will get 490 days. Right. So just we remember beta, this is not tough questions, but click is required in the paper also, beta. During pressure, you know how pressure is there. Now this is last question, students, for I can say today discussion of JEE Main 2024 22nd shift. An ideal gas of a molar mass is 50 gram. Is given 300 joule heat at a constant volume. Okay, constant volume. Okay, then bacha, I hope no. This point you can do underline beta. This point, student, you can do underline beta. This is what constant volume. Okay, so heat is mentioned, bacha ji. So you can use this formula directly. Delta Q is what? N CV delta T. Simple beta. Delta Q, students mention. I can say one student, I can say was with me. I can say just beginning of class until now. Heads of beta for your interest. Now, beta, this is you can say beta 300. I hope beta you remember. N is what beta? This is my dear given mass upon beta g. This is molecular mass. Given mass upon what beta? Molecular mass here. So this is beta, I can say molecular mass upon beta given mass how much? 50 gram. CV beta mentioned here 7 by 2 R. 7 by 2. And R beta what you can take? 8.3. 8.3. And what's the delta T beta? Because mentioned a constant volume if temperature changes 20 degrees Celsius to 50 degrees Celsius. So my dear, what is delta T here? This is what 30 degrees Celsius. You can multiply it as the 30 degrees Celsius. Simple. But I can say this is and this is cancel here, right? 5 to the chain. So you can say 3 into what? 10 to the power q, bacha. This is upon beta is 7 into you can say 8.3 into 3 beta. Yes, this is cancelled. A is equals to m beta. So we can write, my dear, 1000 upon beta, 7 3 the 24, one decimal, 8 7 the 56, and 2 beta. This is what you can say 58. This is number charges. Solve further beta, you will get some values. So all the best, student. Those will go to write actually coming days of J mains. Just stay connected as is fine. Now, students, I'm going to this terminate live session. All the very best, everyone.